Hello, welcome back to Mastering Statistics. Here is finally the famous correlation coefficient. I didn't want to really hit you with that in the last section in all its glory because, as you can see, it's an ugly equation. But now, even though the equation is ugly, you should know exactly what this correlation coefficient tells you. Basically, if this R calculates to be 0 for the data you have, there's no correlation between the pairs of data that you have. It's random. Right? If the correlation coefficient is positive and close to +1, the maximum value, then you have a straight line with these points lying on the line, and so on. We've looked at that again and again. Now, before I talk about this a little bit in more detail, let's go ahead and plot these points, because this is the example that we had talked about earlier, the age of a child and the number of diapers per day. So in order to plot in Excel, this is the version I'm using. Your version might look a little different, but basically you highlight the data that you have. You can even highlight the titles with it. And you're going to go to Insert. So normally you're on the Home tab. Go up to the Insert tab. Go over here. You see all the charts. You've got bar graphs and all kinds of things. This one is basically, or this one down here is the scatter. Go ahead and click it. Now you have options. You can connect them and so on. But for scatter plots and statistics, you don't want to connect the dots. So let's go ahead and leave it like this. You know, it turns out I don't really like that title being there. Let's go ahead and make it larger. So you can see at a glance what's going on here. Here is the axis of age of the child. As the age of the child gets older, it appears that the number of diapers that they're using per day goes down to 0, which makes sense. Now notice that this is not a straight line. These four numbers look to be almost in an exact straight line, but you have one up here that is not along that line. So this is not going to be a perfect correlation of data, but it looks to be pretty strong to me because I can draw a mental line through this guy and get pretty close. Now, in order to talk about this a little bit more, whoops, that's not what I wanted to do. Let me go back and zoom in a little bit. So I want to go zoom. Let's pick, let's start out with 125 and see how close we get, because I do want to talk a little bit more about it. Okay, that's pretty good. There. This guy is the famous correlation coefficient. We're going to calculate it for this data here. We're going to do it in steps, though. So you see what you have here. The letter N is the number of data points you have, the number of pairs you have. So in this case, N is just number 5. 1, 2, 3, 4, 5. There's 5 sets of data points here. Now the X column is what we call the independent variable age. So we're going to label this here in a minute, but basically this is going to be the X values here. The Y values are the ones you plot along the Y axis, the dependent variable. And so that's going to be the diapers per day. So anywhere you see X here, you need to be looking at these values. And anywhere you see Y here, you need to be looking at these values. Now, normally with equations, in calculus, physics, even in statistics, I try my best to derive them and show you where they come from. But in this case, the correlation coefficient, this equation, we could go through it, but it's so long that honestly, it's not worth the effort to do it. I mean, I don't like brushing off things like that and telling you things aren't important. But the point is that when you calculate this, and I'll show you how to do it, you're going to get this number. The number that comes out of it is important. Now, how do you get this giant expression? I'll tell you in words essentially what you're doing. What you have here is a set of data points that appears to trend down. It's got a negative slope. So for this particular set of data, we should expect a negative correlation coefficient. A negative correlation coefficient, because this is a negative slope here. Now, if we were to mentally draw a line that passes as close as we can through these data points, let me ask you a question. Which line would be the best line? Would it be this line that goes like this? Would it be a little bit of a steeper line that goes down this?